thank you everybody for coming through. Super excited to share some particle stories with you and some particle tricks and techniques that I picked up over the years. So, I mean, let's jump into it, right? I'll do a little screen share. And if you guys want to jump on and join my screen share, that'll be great. All right.
So Kevin, if you just click that little live icon next to Dale's profile and click watch stream, you should see a portal. And if everyone can just mute their mics while Dale talks.
Thanks, Rick. So is everybody seeing it? Everybody got the infinite void into oblivion. That's what the internet looks like. Everybody seeing it? Are you guys?
Yes.
You guys seeing You guys seeing Unity? That's the important thing.
No, Discord connection.
All right, I'm gonna stop my video stream and I'm going to share my actual stream because
don't you
so
switch your screen to your Unity?
Yeah, you chose applications instead of screens when you shared your screen. So just hang up and then click share again. And then you'll see there's a tab on the right-hand side that says window. Yeah, so you see at the top there screens. Yeah, there we go.
Yes, got it. Sorry about that. All right, cool.
Sweet.
Are we all seeing Unity now?
Sweet.
Yeah.
All right. Well, thanks for tuning in, everybody. Now that we have the Discord stream going and everything seems to be working, for the next 45 minutes, let me entertain you with the wonderful world that is particles. Like, to be frank with you all, this is actually my favorite part of Unity. Sure, Unreal's got metahumans and they've got some fancy mesh stuff, but there's something really, really special about being able to bring atmosphere into your virtual and 3D spaces, and that's really where particles shine. It gives a lot of depth to what you're experiencing, and as VR sort of enthusiasts as we all are, depth is clearly one of the most important aspects to it. We see a lot of it in fog, but particles do, I would argue, particles do more for your sense of depth than fog does. Fog gives you this perception that something's far away, but particles gives you this amazing magical feeling. I use the word magical very loosely, but like it gives you this really special feeling of being in a place. And that's exactly what we're trying to do with VR is we're trying to make someone feel welcome and part of the environment that we're in. So what I thought I'd do is maybe a little adventurous, but I've opened up a brand new instance of Unity for anybody that's like following along, that's not too clued up on what to do and how things work. I thought it would be really cool to like lightning round show you exactly how you might set this up like from scratch. So this is going to be fun. You're probably going to have to put up with me sort of just entertaining you while we talk about while things are like loading and downloading and stuff. But this will be a nice sort of ground level to understand exactly how particles work and how you might set it up from scratch. So first things first, I have Unity 2019.429. It's not as catchy as 0.420, but we got to do what we got to do. VR chat has moved on to 2019.420 as opposed to 2018.420. Sorry.
Actually, moved to 30 today.
Oh, is it 30 now? Oh my goodness!
It makes no difference. It doesn't make a difference.
This is the world we're in. It's constantly shifting. So I always thought it was kind of cute that they made 2018.420 kind of the status quo for a long time. Here we are, times have changed. So we're using 2019.429 in my example, but as Tyson rightly says, these versions change rather quickly. To start out my little tutorial, what I'm going to do is I'm going to grab a couple of assets that are super important. So I'm going to type in Unity particle and just see what comes up in the asset store, right? There are these two really unappealing looking, sort of drab looking Unity technologies and assets, but they are really, really important because they have some really awesome sprites, right? So this Unity particle pack has some really cool sprites, and I'm just gonna download those sprites. And maybe while we're waiting for that to download, Particles is essentially a way of the game engine taking a very flat little 2D sprite. A sprite is just a 2D image, and it takes that little 2D image and it shows you that 2D image for like a couple of seconds. 1, 2, 3 seconds, and then it sort of disappears, dissipates into the universe. And the real magic of sprites is that the game engine is trying to find a way to give you a sense of depth and a sense of perspective by using the cheapest possible method. I think a lot of game development is about trying to give you the effect of realism by sort of working around the technical constraints. If you start to go into like the theory about like fractals and then like nature, it wildly becomes sort of difficult to simulate. So what game engines do is they have a lot of shortcuts. They'll have, particle effects where they just show you a 2D sprite that is sort of presented to you, and it's sort of angled in a way that your camera looks at just right. And you don't want to play with that too much because it's just sort of an effect. It's just a visual effect to sort of trick you into thinking that this is exactly, that it is like a 3D object. Without hammering the CPU or GPU, there are some really cool ways of leading the audience to believe that they are in the space that sort of represents what it actually purports to represent. So it looks like we're just about done importing this, and since it's taking a while, maybe I won't import the other one. But what Unity have done is they know that particles are a big part of having an immersive experience. I see we're 20 minutes in already, so let me try and keep it snappy. Let's jump into it. I mean, I gave you a basic background in what particle effects are. It's essentially just a instantiation of 2D flat assets, right? If that sounds complicated, essentially it's just showing you Mario 2D flat assets, and it's just saying, well, look, there's a thing, and they try not to bring it to your attention because really what it is it's an accentuation of your environment. It's showing you what the environment might look like if you were actually in there, and it's sort of a shortcut because to simulate these things as 3D objects might be a little too complex for our average PCs. So let me show you. Essentially, what we want to do is, if we go to effects here and particle system, we bring up the most basic particle system, right? And this is cool. This is sort of Unity's way of saying, well, this is what a particle system should or could look like, right? I'm gonna sort of start at the top and work my way down this list on the right hand side here. I know you all can read, and I don't want to be patronizing or anything, but there are a lot of cool tricks as you work your way down this ladder. There are a lot of amazing tricks. Some that took me embarrassingly long to figure out. But there are some amazing tricks and techniques you can use that Unity have really provided with us. Okay, so first thing is emission, right? Emission means how many particles are we showing per unit of time. So if I go 200, it throws a lot. And if I go 1, it throws a few, right? Very, very, very simple. I'm going to go with 50 for now, just to show you the basics, right? And sorry, just another note. I'm gonna gloss over a couple of things that I don't think are as important as you might need to know. So I'm going to highlight the important things, and I'm going to gloss over the things that you can discover in your own time. Okay. Most important is emission, right? How many sprites are we showing per second, right? As you can see, a whole bunch of them. Very cool. All right. Very, very basic. Very cool though. If we go down to the second one, we go shape, right? Shape determines what shape we're going to show those particles in, right? So as you can see, by default, we have cone, but we also have sphere. It projects it in the shape that we determine that it should project in, right? So now it's spraying them all over the show. Hemisphere, very cool. If you want to do like a explosion or something, that would be very hemispheric. If you want to do, so we did cone, donuts, kind of cool, for very specific sort of instances. Interestingly, it also shoots particles towards the middle. I have yet to find a use for that, but I'm sure it's useful for something. Box is very cool. So we determine what shape the emitter is, and then we can also here in the additional settings, we can say, specify whether it comes from the edge of the box, whether it comes from the body of the box. Mesh is pretty advanced, but if you have a custom mesh that you want to throw in there in order to distribute your particles, that's kind of cool. Let's not go through all of these really. I mean, edge is the other interesting one. So you have a line, they project from a line, which is kind of actually very useful when it comes to mist and fog and that sort of thing. I mean, I think those are the important ones. Let's go with hemisphere for now, because this is one of my favorites. All right, so hemisphere. Is there anything else that's worth noting? I mean, the arc essentially tells you how much of that shape you want to project to. So this is 180 degrees of a hemisphere. So it's kind of an interesting shape if that's the way that you want to project your particles. By default, it's 360 because, I mean, obviously, sort of expecting spheres and cones and stuff, but you do have the license to play with that. So if you go to hemisphere and you say 5%, it'll be a tiny little pizza slice that you have there, and I'm sure that'll come in handy one day. All right. The mode, random is probably the most common because it just displays these little sprites all over the show. Loop is kind of cool. So as you can see, if we zoom in a bit here, loop goes around in a circle, and ping pong is different from loop because it goes from back and forth. So it goes, 360 to 360 really. Also, it really sort of depends on your use case. Glossing over. Velocity over lifetime essentially equates to like if you want your particles to accelerate over time or if you want them to decelerate over time. I haven't really found much use for this, but it's there. I think a lot of what I'm going to say tonight is about it depends on what you're using it for. A lot of particle sort of experts or particle folks would say that they're VFX artists because the particle is the most dynamic way to portray a visual effect. That's what we did with the mycelia cave. We wanted to bring more effects into it. So you have steam rising, or you have whatever effect you want, really. as soon as there is magic involved, you start to look towards the particle effect. Limiting velocity over lifetime is also not something that's particularly commonly used. Something that I really did want to show you guys that I think is incredibly useful is it force over lifetime? It is. Sorry, there's a lesson that I learned that took embarrassingly long about speed over lifetime. All right, maybe we should just make our way down the list here. Inherent velocity is something that I very rarely use. Also over lifetime. Also, you're welcome to explore these things in your own time, I think. Color over lifetime is really cool. So this is quite interesting. So I've got a bunch of presets here that I sort of use every now and then, but this is definitely one of the best. Color over lifetime really says, well, okay, so we've got this flat sprite, right? And if you go down to the render area here and you go down to material default particle, that's essentially what you're saying. It's just a 2D flat sprite that's being shown the entire time through, right? But color over lifetime basically says the sprite is going to go from, in this instance, from invisible to white to invisible again. And you can do that with like any combination you want, right? So you can go from solid to invisible or whatever. But the important thing to remember here is when it comes to something like explosions, this is going to be incredibly helpful, right? So let's like amp this up, and then we bump up the size, which is it won't be in shape, it will be in size over lifetime, right? So as you can see, with this very dramatic example, you can go from like a really, really humongous looking sprite, and then as your color over lifetime fades it into nothingness, it you can sort of change the size over that lifetime, right? So with explosions, with what else? Fog, maybe. I don't know, like a fart or something that goes from like super solid to very ethereal. You can really get some cool effects with this technique, right? So color over lifetime is definitely one of the most important sort of factors to bring into this. As you can see here, so I've sort of toned it down a little bit, but as you can see, an explosion starts off as quite crazy and then sort of dissipates. That's really where your color over lifetime comes into play. Moving on, color by speed. So another one that, like, it really comes down to your use case. If you need something that changes color by speed, good on you. But like until then, I guess it's an as and when. Maybe a good example of this might be if you start off really quick and you slow down, you might have like a really cool like whooshing effect. It's sort of just difficult to describe these things in words, because essentially what we're doing is we're trying to put into words something that evades words. These visual effects really do evade description in a sense, because that's why they're so magical, right? It's because they are so unusual to describe. So, but that said, color by speed or size, these things really depend on the use case that you're looking for. Rotation over lifetime is quite cool. So I use this a lot when it comes to leaves. So there's a neat little trick you can do with leaves. Let me see if I've got some leaves in this project. No, all right. So cool. All right, this is this is another technique that took me a little while to learn, but since I learned it, I use it all the time. I have a folder called Shaders and Materials, and in there I have. Can you guys all see the folder? Sorry, let me just see if everyone's still awake.
Yeah, we can see.
Anybody?
it.
Yes.
Lex. On the mic next level.
Max,
Next
Max,
level.
text Max.
So I've got this this folder called spreadsheets, right? And there's one here called Leaf that is just absolutely my favorite. This is just so beautiful. So Leaf is a sprite sheet of a leaf, essentially just sort of flipping over and over and over, right? And as a sprite sheet, it looks kind of bland and mundane. But if we go, okay, so the first thing we need to bear in mind is that a sprite itself cannot be used as a renderer for a particle system. We have to create a material. We'll call that leaf. And we'll keep it as standard for now. We'll drag our leaf sprite sheet into the albedo. Importantly, we need it to be cut out, not opaque, because if it's opaque, it keeps the white background, right? So we make that, we go to the material and we say cut out. Cut out is nice and clean. If we were to go to fade or transparent, we might lose a little bit of the solidity of each of those leaves, right? So cutouts are a nice medium. We go back to the particle system, we go on to the bottom, and you have renderer, right? Maybe I should have started with renderer, but the renderer, you can drag in a material into this material slot, and it says, hey, here you go. This is the material that we're going to use for your particle system. Now, since the material is displaying this crazy albedo that has like 100 different leaves on it, what we need to do is just go, okay, well, so there's 1, 2, 3, 4, 5 down, and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 15 across, right? So the particle system, Unity, have very graciously gone and created this cool feature called texture sheet animation, right? And we say, okay, it's a grid, and it's a grid of 5 by 15. Oh, excuse me. It's a grid of 15 by 5. Oh, would you look at that? Now you guys all know Dale's trick to having amazing particles. Is essentially it's a sprite sheet that's being rendered inside the particle effect, and the sprite sheet says go from that nice flat on leaf to a twisting leaf to another flat leaf to another twisting leaf, and that's essentially it. You know, that's how you get the rotation, right? At this stage, it doesn't really look very natural. So let's start to get like a little bit more adventurous, and then try our best to give the audience the impression that this is actually a real leaf in real life, right? How I might do that is to go to size over lifetime, and I would say don't separate the axes. Go from curve. Okay, so the curve is quite nice. The curve is quite cool. So the curve says, all right, well, they've got a bunch of presets here. You can go from like a straight line from 1 to 0. You can do a curved line. You can do, is everybody seeing that? So you can do like a curved line that way. So essentially what you're doing is through this size over lifetime feature, we're saying start as a big sprite and then sort of peter out into a smaller and smaller sprite. Now, if we go to the camera, you can see it's starting to look pretty realistic, although maybe one of the things that an eagle-eyed audience member might notice is that they're all facing in the same direction. So here we go. We might want to sort of inject a little bit of rotation over lifetime, perhaps. We could say separate axes means rotate X, Y, or Z, right? Maybe we don't want to separate the axes. Separate it by two constants, right? So 0 of them, 50% of them will be 0 and not rotate. And let's say 180. So 50% of them now will rotate 180 degrees. So now we have a really cool sort of blend. 50% of them are rotating like crazy, and 50% of them are not rotating at all. Now we're starting to get the perception that these leaves are all over the show, just as we would when it comes to reality, really, when it comes to nature. And I was actually saying to a friend of mine just recently, nature is clearly the hardest thing in the world to simulate. When you start to go into the mathematics of fractals, the mind boggles at the complexity of real life. So essentially what we're doing in the game engine is we're trying our best to simulate a version of reality that is nowhere near as actually complex as reality really is. And that's really what the particle system is a shortcut into creating the illusion of reality, the illusion of nature. So we're using, yeah, please.
Hey, Deke,
Go
I
ahead.
got a question for you. Do you make your own sprites, or are you? Is there a resource where you're getting a lot of them that you could recommend?
The great question. The general go-to is in the sprite sheet that I downloaded earlier, in the particles pack that I downloaded earlier. You'll find like quite a lot of really good ones. Actually, there's a nice little shortcut we can use here. So if you go to the renderer and you go to material and you pick a material, if I've downloaded the Unity basic pack, you'll find loads of incredible assets. I mean, we have candle flames, we have dust puffs, we have dust, we have embers. I mean, embers. Oh, don't get me started on embers. Embers are the best. Explosions, fireballs, flames. So to answer your question, there are loads of really, really cool default assets, but obviously the more time you take to craft these things yourself, the way better aesthetic you're going to get from the final product.
Gotcha.
So while lightning might be cool, or lightning trail is really cool, when you take the time to create your own assets, there's a huge payoff.
Great, thanks so much, Deke.
And really, the skill set that it points to is the Unity. Is the Photoshop skill set. So we're talking about 2D assets here. So whatever someone can do in Photoshop can be directly imported into Unity. So essentially, it comes down to how good is your Unity. How good are your Unity capabilities? And as someone who's worked in Unity for a little, in Photoshop for a little while, I would say this is a massive opportunity for anybody that's any good at Photoshop. This is a really, really great opportunity for them to get involved in visual effects with regards to 3D visual effects. There's a huge crossover. Yeah, I'm constantly opening Photoshop and playing around with things. So it's limited as your asset base is limited, but your asset base is limited to your skill set. So yeah, great question though.
Great, thank you.
I like to create what I can, but I know for reasons of expediency, sometimes it's not always possible or feasible. So the open source community is always fantastic. There's always some really cool stuff out there, but it's advisable that to create or at least adapt your own assets to get the specific effect you want. Okay, cool. So we took a bit of a detour there for size over lifetime, because I wanted to show you how a particle can decrease over its lifetime and fade into nothingness. And you can actually pair this up quite nicely with color over lifetime and say, okay, well, I want it to fade away as well as decrease in size. And then you get a very, very subtle fade off effect, which is really what we're looking for. You know, nobody really notices the point at which a leaf touches the ground. So as game developers, we really should be looking to optimize that sort of experience and have it fade off and decrease in size and keep the real draw call is the emission size, right? Which is the important thing, right? So if we're drawing 10 sprites per second or 10 sprites per 5 seconds or whatever it is, we really want to keep this emission number as low as possible, especially if our frame rates are getting hampered. But that said, you know, it's a lot of like tweaking and give and take. So it's a more, well, I mean, this is really why they call it an art, because it's an art of balancing performance against your aesthetic. If you go with a really low emission rate, performance-wise, you'll be fine. But everybody wants I say everybody, but mainly me, wants the 5,000 particles per second sort of vibe. And, you know, I suspect we'll get there eventually. It's just whether or not I'll live to see it, who knows? Let's move on. All right, rotation by speed. You know, it's pretty much just a rotation module that just is, you know, is going to, it sort of relates to how quickly the particle is moving. Something I haven't found too much use for. Since our particles are looking a little sad at the moment, maybe we should just make them look a little bit better. Let's go with 20 and add a size of lifetime. All right, cool. See, we only have 15 minutes left and we're about halfway through, so let me fly through the rest of this stuff. External forces, never use. Noise is incredibly important, and noise is just so amazing. So noise, essentially, basically, it just makes your particles jiggle more than you might anticipate they would, right? So if we go turn the noise off, they seem quite predictable. When turn noise on, and they start to jiggle a bit, right? And if I ramp that up to 10, they jiggle like crazy. The frequency says how regularly should they jiggle. So if I go with 0.1, well, then they'll have more of a wafty kind of wind vibe to them. If I go with like a 50, then maybe they'll have more of like a bee sort of buzzing to and fro kind of sense to them, right? Quite straightforward, but very, very useful. Especially, I mean, my big focus really is on simulating nature. So you sort of want something that feels natural, which, you know, points back to the arts argument that these things should feel natural. They shouldn't feel forced or unnatural. So there's a bit of art and a bit of tweaking to it, but noise is definitely where you're going to get a lot of that like natural wafting sort of sense. Collision is a very use case topical sort of issue, right? So as you can see here, we've got these little green orbs that are around each particle. That's a collider. You don't really want... the more of those colliders that bump into other colliders, the more physics calculations you're going to have going on inside your application. So you really want to minimize the number of collisions, because it's so heavy on the CPU. So collision is great if you need like maybe I've got a project where some trees grow out of the ground, and to get those trees to land on the ground first and then grow requires some collisions, but the physics cost is immense. You know, also a use case specific sort of example, but collision essentially means that your particle will bump into other particles. You can do it by planes or by worlds. So like, is it going to bump into every other thing that has a collider on it, or is it just going to bump into like maybe the ground? This is Unity's way of like making sure that we don't like overcook it, but it's very easy to overcook your physics simulations. All right, let's move on because we don't have much time left. Triggers, I actually haven't used much. Sub-emitters, I haven't used much either. Sub-emitters essentially means that you have a particle emitter coming from another particle. Also very, very like processor heavy. There are certain things that are in Unity that are geared towards like 2D games or games that are projected on a screen, which is fantastic for them. But for us in VR, we have to always be mindful of the optimization at the optimization aspect of our experiences. It's incredibly important that we try and hit that like 30 to 60 frames per second limits. I mean, you know, for those in the game dev community, it's like 90 plus because they're so used to only projecting on one screen. But we in VR, we have two screens to project to. It's one screen for the right eye and one screen for the left eye. So for us, the optimization issue is extra tetchy, and the frames per second issue is extra tetchy. That's not to say that there's an excuse to having low frame rates. You know, I'm certainly someone that is still definitely learning the ropes of trying to get to the optimal frame rates of VR experiences. But you know, the 2D world certainly has a leg up on us because they have essentially twice the GPU and twice the CPU speed that we do, because they have to render for half of the rendering that we do. So, you know, optimization is very important, he said begrudgingly. Noise, collision, triggers, sub-emitters, texture sheet animation. This is quite a cool one. So I sort of glossed over this a little bit earlier, but essentially what you're doing is, if in your renderer and in your material slot here, you're using a sprite sheet, you need to tell the particle system, okay, look, we're not showing one particle, we're showing lots and lots and lots of particles. And the texture sheet animation area is exactly where we define that. We say, okay, look, yes, it is a grid, and we're going to go 15 by 5. And that's why this particular particle looks so tasty. It's because I'm telling it, well, look, expect 15x and expect 15y per second. And if you don't, it's going to look crazy and it's going to look awful. So this is the exact spot where we define a texture, a sprite sheet for a particle system. Lights, I wouldn't touch with a 10-foot pole because, as I said, optimization is important. Trails is fun. Trails is a lot of fun. I love trails. All right, so check this out. So we have Embers, right? Embers is a good friend of mine. Embers has like a very, turn off the sprite sheet animation, and Embers is essentially just basically a dot, right? And if I turn on Trails, it gives me the pink disaster material because I haven't set a material. But if I go to lightning trail, this is just a standard Unity asset. If I go to lightning trail, which is even better than Embers, essentially what we're doing in trails here is we're saying, okay, expect the trail material to be lightning trail, and it looks like that. And then what it does is it stretches that one sprite, and it can become a long sprite, right? Now, if you pair this up with noise, it looks insane. I mean, look at this. This is bonkers, right? I mean, this is really going to tax your computer a lot because it's doing sort of real time. What is it? I suppose destination mapping, you might say. and you can really go crazy on this, and it's got a lot of permutations, right? But to get back to trails, the ratio means how many tails we want per particle. The lifetime is how long we want it to last. So 0.5 is quite interesting because the trail lasts half as long as the particle lasts, right? Minimum vertex distance means how smooth do you want that line to be. So if we go to 0, they're going to be super smooth. If we go to 1, it'll be a bit more jagged. If we go to 10, it'll be even more jagged. You see what I'm saying? It's really depends on what your aesthetic is. If you go to 100, it'll look. They're basically just straight lines. They're just janky straight lines. I wanted to get a nice like sort of semi-curve sort of thing going on here. Okay, there we go. So at a minimum vertex distance of 5, you're starting to get like a bit of a zigzaggy vibe going on, right? If you want really smooth lines, you go with 0, but the higher that number is, the less taxing it's going to be on your machine. World space is great because that defines whether or not that particle system is going to exist in the world or if it's going to exist on whatever it's put on, right? So if I pop on a cube and I put that over here, right, and I move that cube around, that's what they call worlds. That's what they call local space, right? I mean, so I move the cube and the particle system goes with it, right? That's local. Which is, if I go world space, then it's going to, no matter where I put that cube, those particles will exist in the space with me. Ah, here we go. Sorry. Jeez. So it might seem like a very innocuous sort of check mark, but essentially what it means is that these trails will stay with whatever I attach it to or not. If you guys have seen the Watcher is an avatar for the mycelia world that has world space on, which means as anyone who's wearing that avatar moves, the particles go, okay, we're not in the same universe as that avatar. We're in this larger universe that has all the particles, and we're going to try our best to keep up and sort of accommodate. Whereas if you say world space off, then it goes, okay, well, me as a particle, and it is intrinsically attached to the object that I'm following. So it'll look like the particle is very much adhering to whatever its parent object tells it to do. Please let me know if that was a little confusing or a little vague. I'll gladly explain in more detail. Custom data is not really something I've played around with much. And then the renderer, I mean, maybe I should have started with the renderer, but the renderer is super important. So the render mode is whether we see a billboard. That means each of these circles, each of these sprites is displayed as if a billboard were facing your camera. Stretch billboard, horizontal billboard, vertical billboard, those are just different ways of displaying a billboard. A mesh is quite cool because you can select a mesh, like maybe let's go for a sphere, right? And we'll pick a material that might work nicely for a sphere. Maybe this bright button. Yeah. Oh, look at that. All right, cool. So now computationally, we're doing a hell of a lot more than we were a second ago. I mean, I can feel the heat coming off my computer because I told it to do meshes now. So what it's doing is, rather than instantiating a flat picture, a flat 2D picture, it's actually instantiating a 3D object, right? And that's why you can get the cool like shading and shadows and these sorts of things, right? This is exponentially more heavy on the processor, especially the GPU, because, well, actually GPU and CPU, because it's doing the geometry calculations as well as the graphic calculations. If we hide the trails, you can see what I'm saying, right? Now, maybe something to, I mean, we've only a couple of minutes left, but maybe something important to note is when it comes to meshes, a sphere, if you think about it, the shape of a sphere has a lot of like angles to it, right? It has a huge amount of geometry. There's loads of little vertices that are saying, okay, well, here's a curve, and here's a curve, and here's a curve, and here's a curve. So a sphere mesh in your renderer is gonna be horrific when it comes to rendering it, especially in VR, right? If we ever use, and I mean super if we ever use a mesh renderer for particles, it should be a cube or a pyramid, but I advise against it unless you have a lot of control over the performance requirements of your PC or your audience. A cube at least has very simple geometry, so it's much more simple. So if you're creating a avatar in VR chat, it's advisable to, if you go this route, to use a cube or a pyramid. But yeah, it's very edgy, and you're probably gonna piss a lot of people off. None. I actually don't even know why that's there. Let's go back to billboards. Material, like I said, you can actually use any material you want. You'll see like a lot of them render quite differently, and it's quite interesting to like play with how they interact. I mean, it would be cool to test this out with like video textures, or I mean, sprites are the easy one, but I mean, you can go nuts. It's really open to your imagination as to how you want to try out different materials. Yeah. Particle size. I mean, yeah. Maybe something interesting is the flip and roll. You can flip and roll different particles in a certain way, but it's a little tricky to fiddle with. But I mean, I think it also comes down to your use case. Casting shadows, you always want to keep off, really, because to render shadows is one of the most expensive things, and we don't really want to render shadows on in VR ever, really, unless we absolutely have to. And if we do have to, it needs to be a directional light, a single directional light with hard shadows. Shadows sorting. I mean, I think that's about the gist of it. Hey, guys. Any questions? I think we sort of run out of time, but and thanks all for sticking through this, and I hope you've picked up something that's interesting. Any questions at all?
Thanks, Dick.
That was awesome. Thanks, Dale.
No, thank you.
I do have a question, and that's could you connect a particle emitter to audio link and have the particles like the emission or something like that be based on like baselines or different frequencies?
Yes, Mike, absolutely can. This is something I've sort of experimented with a little bit with myself. I'm not 100% sure on the performance ramifications. I assume there would be some, because essentially you've got a bunch of different entities that are all demanding to be reactive to in real time. But that said, it is 100% possible to have audio reactive particles. Yes. What you need to do is you need to, in your material here, you need to make sure that's an audio reactive material. Very possible. Yes.
Thank you.
Yeah, Lex. I mean, something that I have sort of like bumped up against with respect to particle avatars is that I love to start from scratch and then create an aesthetic that I like, and then slap on the avatar script afterwards. The big punji pit that you got to watch out for is your scaling, right? So what you really need, I mean, more than a default avatar is scaling right. I have a really nice thing called human scale that I keep on searching for. That sort of is a nice little shortcut. Here it is. It'll be in 3D.
Man, you got to use Pumpkin's avatar tools. It has a scaling tool which puts a standard sized what do you call it? A measuring wall behind you with different sizes, so you can just rescale your avatar and see exactly how high it is in a VR chat world. It's like
That's a good point.
Fantastic tool on the Pumpkin avatar tools, even if you just use it for that.
Good point, Tyson. Yeah, there is Pumpkin's avatars tools is in the, let's find the prefabs list. I mean, this is just like one of the best fucking resources in the universe. I mean, this is just bonkers. I mean, so Cyan Emu. I mean, this is a bit off topic, but I'll share this link with everybody in the group when we're done. But like Cyan Emu allows you to test your code inside the editor. Uno and Sharp lets you run C# code inside the editor. VR World Toolkit like tells you, Dale, your frame rate is too low. Calm down your bloom. Cyan Trigger, awesome. Like
Calm down
I'll
your bloom, Dale.
Calm down your bloom, bro. Yeah. So as Tyson said, Pumpkins, I think, is over here. There we go. Pumpkin's avatar tools. Now this is a really, I mean, if we were doing like an avatar specific tutorial, this is absolutely essential. It's so good. And Fiona, who did a world hop, if I'm not mistaken, I unfortunately I missed it, but Fiona whipped up this amazing tool that helps you do different poses of your avatars, and like Tyson says, can get your scaling right. I just like to throw in like a 1x1 human avatar just to make sure the scaling's right. But Tyson's got a good point. Like Fiona's got some really good stuff.
As long as you don't want to use your hands. If you want to use like a particle in your hand to like grab things, you'll have to have a human. Otherwise, no. It'll just.
Looks like I have the chat SEK in. I'm not sure if it's the avatar one though. Oh, maybe it is. So there's a default VR chat avatar. Okay, that's not the one I was looking for. But there's a default in the latest avatar SDK. You can drop that in, right? And all you really need to do is go into the body, right? Like keep the skeleton, right? Because the skeleton tells you where the arms and legs are and the head and all that stuff, right? But if you go to materials and go boop, right? You've got a skin mesh renderer which says, well, this is where the materials go, and you've got no materials. You've got the entire skeleton all set up. So if you attach that particle system to, say, the upper chest, and we attach the VRC Oh, see. Oh, pedestal. Oh no, sorry. I've got the world's SDK loaded on here. But if you add your SDK script onto here, your avatar SDK script, you can basically just attach this to whatever part of the rig you want. So whether it be the head, the chest, or the hands, as long as when you go to actually launch and upload your avatar, that you have got the what is it? I think it's the maximum number of particles. As long as you wrangle that part in, you should be fine. But I would say it's definitely advisable to use an existing skeleton because you can get the hands, the legs, the feet, the head, all for free, and you don't have to render the actual body itself. Although you might want to remove the mesh. Any other? Thanks, Lex. That was a good question. Definitely something I wanted to touch on. Yeah.
All right. Love you loads, and I'll see you tomorrow. Love you loads.
Love you loads too, Lawless.
Is that Lawless? It's your boy Lawless.
Yeah. Wait, am I on? Oh, I'm on. Oh, yeah. Hello, everyone.
Good to hear from you, bro. How's the boat?
It's good. Today I got a delivery of a book called The Pictorial Great Eastern, and it's got loads and loads of pictures in it. And I also went to Greenwich Maritime Museum, and they let me have a look at the technical boat plans for the Great Eastern. So yeah, I'm gonna go back over. It's £80 to get a proper print, but I think I'll be if I take some pictures and kind of measure the pictures right, I should be able to get the whole plans. So yeah. Sorry. Oh yeah, sorry. Let me go back on mute. Sorry. Thank you for a great lesson, and I'll see you guys.
Cool, man. Good to hear from you, bud.
Thank you.
Yeah. Maybe one more like little parting shot while I'm at it. I think, just to sort of relate to what I said earlier about depth and the sense of depth. Particles really is a way, especially in VR, to get your audience to feel like they are in a actual place. There's so much flatness, especially when it comes to, maybe this is a chip on my shoulder when it comes to Quest, but there's a lot of flatness when it comes to Quest worlds, and the hardware can handle what it can handle. So no knocking it, but what I'm after personally in my own work is to give the audience the perception of reality, that perception of depth, that perception of actually being in a place, that sense of place. And I think particles is definitely an integral part of that, and I'm really, really looking forward to what you guys can show me over the next 6 months or so about how in what interesting directions we can take this, because I might have I've learned some hard lessons along the way. It took me a long time to figure out how to get particles to swirl and stuff, but I would love to see what you guys can do with it. So please share every little bit that you can make with it, and please share your progress, because I would truly and deeply and honestly appreciate it. Because I myself am also learning this and trying to figure out the best ways to implement this. So thank you all for your time, and looking forward to hanging out in now, I guess, at the meetup.
Nice one. Cheers, Deke. Thank you.
Great. Thanks, Deke.
Thanks, dude.
See you around in VR.
Thank you, Anne. Thank you.
All right. See you guys now.
Take care.
Cheers.
Thanks.